Hello everyone, welcome to AI Content 49. On this channel, we break down complex AI tech stories into simple and relatable ideas. And today, we are diving into one of the most fascinating journeys in technology, the evolution of AI. Hey guys, when you hear the word AI, most people feel like it's something that just showed up in the last 5-6 years. ChatGPT, image generators, all this recent hype. But here's the interesting part. AI is actually older than the internet as we know it today. And in this video, we will break it down in a simpler way, how it all started, why it failed so many times, and how it came back stronger to become what we're using it today. Let's get started. It all started with a very simple question. Can machines think? Back in 1950, Alan Turing asked this. Not compute, not calculate, because calculators have been around since 1623. We're talking about something much bigger than that. Something deeper. Thinking, understanding, responding like a human. So Turing came up with something called Turing test. And yeah, he named it after himself. I mean, fair enough, he came up with the idea. According to the Turing test, if you can't tell the difference between a machine and a human in a conversation, that machine can be considered intelligent. But here's the catch. The Turing test didn't give us the final answer. It wasn't like one day we all said, okay, machines are officially intelligent now. Instead, it gave researchers a direction to move in. And soon after that, the field got its official name. In 1956, at an event called Dartmouth Conference, a scientist named John McCarthy gave this field a name, Artificial Intelligence. And that's basically where AI as a proper field started. Now here's the interesting part. Back then, researchers were very confident, like really confident. They believed we'll build human-level intelligence in just a few decades. And honestly, the early results looked promising. There were programs that could solve math problems, play games, and even chat with humans. After this, scientists started building some of the earliest chat programs. One of the most famous examples was ELIZA, built in 1966. It works this way. You'd say something like, I feel anxious, and the reply would be, why do you feel anxious? Basically, just rephrasing what you said. It didn't really understand you. It was just recognizing patterns and responding based on that. So what did we really learn from this? Machines can imitate humans to a certain extent, but true understanding that was still missing. But then reality kicked in. These systems were a bit like a student who just memorized answers for one exam. The moment you change the question even slightly, they just completely lost. And that's when things started to slow down. This period is called AI winter. Not once but twice. This happened in 1970s and then again in the late 1980s. We didn't have enough data, we didn't have computing power, and honestly, two big promises. So funding dropped, interest faded, and for a while, AI just went quiet. After this, scientists tried many things out. So instead of telling machines exactly what to do step by step, they started asking a very different question. What if machine could learn from the data? And that's when machine learning or ML comes in. So instead of writing rules like if this happened, do this, we started feeding machines the data, examples, and patterns, and then we leave the response to them. But here we were still lacking the data to feed to these models. Also, the models were very basic, so model could not perform up to the mark. But before machine learning could fully take off, something interesting happened. In 1997, IBM built a system called Deep Blue, and it defeated the world chess champion Garry Kasparov. This was a huge moment, because chess isn't just a simple game. It needs strategy, planning, thinking ahead. So when a machine actually won, people were like, okay, this is getting serious now. But here's what most people didn't realize. Deep Blue was not learning like modern models. It wasn't learning from the data. Instead, it worked using program methods, checking million moves, predicting outcomes, and following the rules designed by experts. So basically, it was very powerful, but only within chess field. If you come out of chess, it's completely useless. In 2012, there was a competition called ImageNet. It was all about image recognition. The models have to recognize objects in the images like cats, dogs, or cars. And in that competition, a model called AlexNet, built by Geoffrey Hintzen's team, came in, and it shocked everyone. Here's what happened. The best systems before this had an error rate of around 26%. AlexNet brought it down to 15%. That was not a small improvement, that was a huge jump in accuracy. In simpler terms, it suddenly became much more better at recognizing images than anything before. And that's what kicked off the deep learning revolution. So what actually changed? Why did deep learning suddenly start working after all those years? It wasn't just one thing. It was three things coming together at the same time. First, the data. The internet exploded. We suddenly had access to millions, even billions of images, text and videos. Basically, machines finally had enough data to learn from. And honestly, before this, AI was like a frog in a well. It could only see a very small world, very limited information. But now, suddenly it had access to the entire ocean. And once that happened, it could explore, learn, and improve at a completely different level. Second, the computing power. GPUs originally built for gaming turned out to be perfect for training neural networks. Kind of ironic, right? The same hardware used to render game graphics is now helping machines understand the world. Third, the better algorithm. Neural networks had been around for decades, but now they became deeper, more refined, and actually useful in practice. And when these three came together, that's what we got the deep learning revolution. And after that, things didn't just improve, they accelerated. In 2012, something incredible happened. Google DeepMind's AlphaGo defeated world champion Lee Sedol in the game of Go. Now, if you're not familiar with Go, it's much more complex than chess. There are more positions in Go than atoms in the universe. So this wasn't just a win, it was a statement. And then came the biggest shift of all. In 2017, Google introduced something called transformer architecture. Now I know that sounds a bit technical, but this is the base of almost everything you see in AI today. Models like BERT, ChatGPT, all of them are built on the same idea. These are called the large language models. And this is where things truly changed, because unlike systems like Deep Blue, these models don't just follow fixed rules. They learn patterns from massive amount of data. They understand context, what you mean, not just what you say, and they can generate completely new content. Now this is where it gets real for all of us. Let's take ChatGPT as an example. It was released in 2022 November, and what happened next was insane. It reached 1 million users in just 5 days. Just think about that. To put that into perspective, Facebook took around 10 months, Instagram took about 2.5 months, and Netflix took over 3 years. And ChatGPT, just 5 days. That tells you something very important. This wasn't another tech product. This was a major shift. And tools like Gemini are built on the same foundation, transformers. So today, when you're using tools like ChatGPT or Gemini, you're using something built on decades of evolution, from Turing's idea in 1950 to the powerful AI we have today. AI has moved from just being a tool to becoming a collaborator. Earlier, it just used to follow instructions, but now it helps you write emails, it helps you with the code, it helps you design, learn, and even think through the problems. And the most important thing is, this is just the beginning.